Hey, Kat.
Hey. I got the lives working, so we're good.
Woo woo.
Woo. Doc Z, I'm gonna ask him to pronounce it for us, but he should be on in like a minute or two.
Sweet.
Yeah. Just need to contact. Okay. There's somebody named Wong in, oh, let me make you co-host. Wong in the waiting room. Oh, there's E Wong. Okay, he's here. Let me know when you're ready to add him in. But I'll talk to him. Just
I'm ready whenever you are.
we are live already. We are already live on all of our social media.
Sweet. Hello, hello.
Hi, Dr. Wong.
Yes.
Hi. This is Kat. We were in communications a while ago, and unfortunately, our emails didn't come through. But how
Okay.
are you?
I'm fine. So I changed the file, but in a hurry, I think I sent a wrong file first. But
Oh, don't even worry.
Okay.
And then just let you know, Christy is here. She is the host for tonight. She's
Okay.
going to go ahead and introduce RMDS Lab, and that will probably be about 3 minutes long. We'll start at 6 on the dot, or maybe 6:02. And
Okay. No problem.
yeah. And then once she introduces you, you're good to go.
Okay. Thank you.
Yeah, no problem.
Thank you.
Thanks for doing this.
So the audience basically is interesting in big data. Data is in data science. They might not have the economic background. So that's the reason I draw two slides in my fall. I offer a class with Professor Gary Graffey at Duke University and Professor Xingyu Qing in Japan to the UIBE Master Students Program. So I take two picture, so two slides insert in the in the slide. That's the I did this afternoon. So I thought, oh, maybe it's different with I lecture to in the past, or most is economic background. So this group might be very different.
Oh, yeah, but for sure they're going to still appreciate all of this.
Yeah, I will try to using more samples, try to explain the concept behind the decomposition framework.
Oh, great. Yes. Perfect. And then also Erica's here too.
Okay.
Hello.
Eric, so we communicate a lot. Thank you for giving me this platform to present my research work. I'm very glad to do so.
Oh, that's no problem. And thank you for taking part in the interview as well.
Okay. So this afternoon, I sent you a few files. I'm sorry to disturb you because you say, I thought this group audience might be different with what I teach in the past. They say mostly they are economic background. They say, so I think I cannot directly go to the how to identify and measure GVC. I plan what is GVC. So that's I pulled 2 slides from my the course. I offer a class this fall with Professor Gary Graff at Duke University and Xi Qing at Tokyo University. So basically, so I withdraw. I take two slides from there to insert this lecture slide. I just thought, oh, I think this group audience might be very different. So I have to say something very simple in the beginning.
Oh yeah, that's not a problem. A lot of people make a lot of last minute changes.
So you can disregard the one is a big. I think it's 7 meg. It's too big. That slide. That's you say. We offer a master class for master level course for the students in UIBE, the University of International Economics in Beijing. So that's for that class. It's different in here.
No, that's no problem. We'll make sure to upload the correct one.
Yeah, because this correct one I dated is 2021.
Yeah.
So how to spelling the RMDS? Does say RMDS lab?
Yeah,
right?
RMDS lab.
Oh, the RMDS lab. Okay.
Yeah.
Okay.
And then how do you want to, can you pronounce your name one more time for us just so we know when we introduce you?
So in China they call me Wang Zhi, but in American they call me Z Wang.
Oh wow.
Let's say Dr. Wang. That's I think that's better.
Okay, great. Thank you. And it looks like we have about 4 minutes. So if you want to just go ahead and get some water or anything, you definitely have some time. Same with
It's
you.
okay, no problem.
Okay, great.
So because of the pandemic, we are all in home.
Yeah.
All the travel is canceled. So
Exactly. Right. We're ready for these things.
So you say I can share screen from my side, is right?
Correct. Let me let me give you that permission. You can share screen. And then I forgot, I wanted to ask for the questions. Did you want to go ahead and read the questions in the Zoom chat yourself? Or do you want Christy to give them to you at the end of the presentation?
I think it will be better if they raise the question during my lecture, so I can answer them.
Yeah, you know what? It's that way actually seems to work the best. So that's good.
But if they have question in the end, the question can send it to me, so I can answer them by email.
Got you.
So how long this your lab? How long? I think you it's pretty large platform, is right?
Yes.
Online platform have 32,000 participants. It's quite a big crowd.
Oh yeah, but you mean on on GRMDS?
Yeah.
Correct, right? Yeah, we're really proud of it.
Okay. So how long?
I thought you meant on live right now. It's like, whoa, what am I missing?
How long your history is always 3 years or 5 years? How long you already?
We've actually been going on for about 10 years doing like community events. Yeah, but our first employee, like we just started really building up about 3 years ago. Correct.
Oh, you want to scale up?
Yeah, keep going. We're on our way.
I think a lot of interesting lectures. Some like the Bao Shuming, I know him. He know me too.
Oh wow, really? Small world.
Bao Shuming. You can ask him. I know him.
Okay, I will. I'll check. Okay.
He did a lot of work on China.
Oh yeah, right. Exactly. It does look like we're starting to get a lot of people are starting streaming. So, oops, excuse me. So, Chrissy, I think we can go ahead and just start at 6:01. Oh, you're muted.
Sounds great.
Okay, so Dr. Wong, I'm gonna go ahead and start letting people in. Christy's gonna do just get them excited. She'll start at 6:01, and then once she introduces you, you are good to go. Just as a
Okay,
reminder.
thank you very much. Thank you.
No problem. So I'm gonna go mute now, you guys. I'm gonna let everyone in.
Okay, thank you.
Hello, everyone. Welcome as you're joining. Thank you so much for joining today. Welcome, welcome. We're just going to wait a few minutes to begin today. While we're waiting, take a second and follow us on all of our social media channels, LinkedIn, Instagram, YouTube, WeChat, and Facebook. Make sure you don't want to miss out on any upcoming webinars, exciting stuff we have going on, different trainings we have coming up as well. We're super excited for everyone to be here today, so thank you for joining us. We also are streaming live, so you want to check that out as well. Welcome, everyone. They're having some friends join us. Like I mentioned, make sure you take this time, follow us on all of our social media channels. We always like to broadcast, promote, and stay connected that way. LinkedIn, Instagram, Facebook, WeChat. All right, well, we're going to get started today. So thank you again, everyone, for joining us today. Don't forget to answer or ask all your questions and leave them in the chat box. I'm so excited to be your host for this evening. My name is Christy Fisher. I'm a part of the business development and sales team here at RMDS Lab. Thank you for having me today. We are so excited to have you all enjoy Dr. Wong's Identifying and Measuring Global Value Chain Activities. This presentation is for an audience interested in global value chain related issues and using various production-based GVC indicators. RMDS Lab is a data science community that specializes in helping researchers and data scientists worldwide to excel in a new era of big data and cognitive computing. And if you're not already a member, make sure you join our ecosystem today. RMDS Lab was founded in 2009 by IBM Chief Data Scientist Alex Liu, and we're headquarters in Pasadena, California, with partners worldwide. We serve more than 37,000 members, and we have affiliates around the world. The RMDS ecosystem platform is a one-stop shop for those working on data-driven projects. Our vendors specialize in a wide variety of data science services, including data sets, workflows, data quality assessments, and industry-specific training. The Recommender engine connects data scientists with the right analytics and machine learning resources that enables the discovery of new tools to increase project success. Without further ado, we are so excited to have Dr. Wong here with us. Dr. Wong is a Senior Policy Fellow of Schar School of Policy and Government at George Mason University. He is also Professor, Founding Director of the Research Center of Global Value Chains at the University of International Business and Economics in Beijing. His major fields of expertise include value chain and global production network, measuring trade and value economic integration among Greater China area, Chinese economics, and international trade. We're so excited, and thank you, Dr. Wong. Please take it away. The floor is all yours.
Thanks a lot, Christy. So thank you, kindly introduction. So I'm very happy to have this opportunity to use the RMD Lab's platform to present my research and discuss with the interesting audience. So today, let me share my screen with you. You can see my screen?
No, we do not, Dr. Wong. Can you try one more time?
Let me try here. You can see it now?
no. Are you pressing share screen at the bottom?
Yes, I did. Let me try another one. Sometimes it doesn't work. Okay. Sorry. Oh, yes, I didn't press this. Okay. Should be work right now. Is right?
Yep, here we go.
Okay. Okay. So today the topic I would like to discuss is the.
I just want to make sure we're not seeing a PowerPoint, we're seeing Zoom.
Okay, you see right now?
Now I do. Thank you.
Okay. So the topic I want to discuss today is identify and measuring global value chain activities. So my presentation will have 5 parts. First, I want to introduce the accounting framework, how to identify global value chain activities through decomposition production activities. So I will first illustrate the economic intuition behind the decomposition, because the audience might come from different disciplines. So I will briefly introduce what is a GVC. Then I will briefly outline the major mathematical derivation behind how we arrive at the decomposition formula. In the second section, I will try to using 1 or 2 numerical examples to explain how to apply, how this decomposition method can apply to the real world data. Then I will introduce the online data structure of the UIBE Global Value Chain Index. Then last 2 parts, I will talking about the global value chain participation based on the decomposition of production activities. Finally, I will introduce what is the limitation of current method and introduce briefly about the current work we are doing, the working in progress. So let's start. So what is global value chain? So many of you, if you study economics, you will know this. The global value chain is a series of stages involved in producing a product or service that is sold to a consumer, with each stage adding values, and with at least 2 stages produced in different countries. So that's briefly in plain English. So for example, like a bag, the bag produced in Finland with parts from Italy, Japan, and Malaysia, and export to Egypt. That constitute a global value chain for bag. A country, sector, or firm participates in a GVC if it produces at least in 1 stage in a global value chain. So the bicycle, you see, is heavily traded in the world, with the 49 countries exporting more than 1 million bicycles or parts in 2017. So if this graph I taken from the World Development Report 2020, as released last October, basically, so you can see, even very simple bag, come from different countries. That's the nature of contemporary production system. Then we define the global value chain in economics. In more precise economic term, a global value chain involves the fragmentation of production across countries. It is a production process that involves at least 2 countries, in which embed factor content of production cross-border multiple times. It is often associated with their international trade in raw materials, such as tin or aluminum, in intermediate inputs, such as car parts or secret, okay? Or in task, that's in service, such as the back office services. So what is the common feature here? It's basically, if we're talking about global value chain, it have to involve or associate with intermediate goods trade. It's not final goods trade. Have to involve with intermediate goods trade. So a firm can participate in two ways, participate global value chain. We call the backward participation is importing foreign inputs for processing and further exports. So this backward participation. The forward participation is exporting inputs that are incorporated in the export for other countries. That's produce innovative goods used for other countries to produce exports. So this picture explains, you see, the forward participation is the raw material parts and components exports, then go to a after the assembling or processing, go to a semi-finished goods. So in this middle state, they take both backward and forward participations. They finally go to the finished goods factory that produce final goods for consumption. So that's basically is a global value chain. So those are economic concepts, but this group will be interested in data science. So all the concepts have solid data to support. So in order to identify global or major global value chain activities, you have to have the real world data to support. You see, because the value chain activity depends product and services that are used as many inputs. So the first major issue to be solved in the GVC measurement is dividing the trade flow or products into intermediate and the final goods. But hundreds of thousands of products are traded in the world. For example, the US customer have 10-digit harmonized tariff schedules, we call HS code, that have 10,000 for export or imports, okay? So even within the 10-digit products group, the heterogeneity is tremendous. So if, for example, you see the telescope is a 8-digit code, but under the 8-digit code, they have different type telescopes. Some used for the high school, some used for even for the looking for the aerospace. So it's very heterogeneity even within the 10-digit HS code. So properly identify their final use is not very easy. To overcome such difficulties in GVC measurement, factor content or value added trade is emerging as the mainstream measure of cross-border production sharing activities, because the production factor such as land, labor, and capital are relatively easy to classify and only have numbers in numbers. The production activity based on factor content embedded in various products can be classified according a uniform standard. So that's make us the analytical work trickable. So if you do the 10-digit code, it's too much. So you don't know. We have a way. I know UN standard deviation have a way to help you to classify the 6-digit XS code, go to end use categories. But it's very, very complex. So the mainstream right now is using the factor content as the way to classify products. Okay, in an era when traditional trade dominated international commerce, factor was less mobile across countries, and the factor content embedded in final products across national border only for consumption. Okay, but in today's world dominated by regional or global value chains, production factor such as FDI directly cross national borders, but a large portion of factor still do not move within countries because they have immigration constraints. So some countries have capital constraints too, you see. But you see, the labor is much less more movable than capitals today. So a lot of factor content like labors, they are traded, embedded in both final and intermediate trade floor across nation borders. That's the situation. So after this kind of economic intuition illustrations, so we will introduce the accounting framework for how to identify and measure GVCs. Okay, basically you say the GVC is in goods trade, related in goods trade. So that means you say we can, based on how much they embed factor content in a product, they cross border how many times, in using such unified standard to classify production activities into 3 or 4 major parts. So this graph basically indicate basically give you the economic intuitions. So we basically use, we have a way using the inter-country input-output coefficient matrix to help us identify, so what is domestic content, what is foreign content. So basically you say, we can divide a production activity for a sector and a country into 3 major parts. The first part we call pure domestic production. So this kind of production, they factor content without cross countries. They just all domestic factors. For example, in the haircut. So the haircut, basically you say, you have to go to a local bar shop to get the service. Okay, in such a service, all the production process, the producer, the supplier, they basically using their own laborers, using their own shops. So they have to invest them to do something, to buy a shop, buy facilities. All those things is domestic factor, produce a domestic products and consume the domestic consumer. So that's the production process is finished within a country. There's no production factor across border for production purpose. So that's the haircut is a very typical, you say, it's domestic, it's a pure domestic production. Then the second type is we call traditional trade. That means in the earlier 20th century or 19th century, like the Portugal win in exchange with England cloth. Okay, that's basically the win is produced in Portugal. Basically, all is the Portugal's labor capital to make this win, make this one, then export to England in exchange England's textile products. With textile products, all the factors is basically produced within England. So that's what we call traditional trade. So the factor content of England and Portugal, they are embedded in one or embedded in textile products cross countries. But the cross country for what? It's not for production. It's for consumption only. So that's what we call this type of activity, production activity, as traditional trade. Finally, we have the third type, basically is the associated with the in-demand goods trade. So the factor content embed such kind of products cross national border for what? For production. So this type of production activity can further divided into 2 types. One we call simple GVC activities. Basically, it's the factor embedded in products cross countries for production, but only within the importing country. For example, when United States import Chinese steel into United States, the US construction workers using this steel to make beams in a house. For example, I bought a house in Brentwood, California. That's using the beam. I heard the steel is come from China. So the Chinese steel, that's embed Chinese labor's activities, embed Chinese steel factories capital, then come embedded in the steel, then go into US border. But this cannot become a final goods to consumed by US consumer. They have to sold to the US construction companies. So the US construction company have their labors, have their capitals, they have machineries, so they have her labors to build the building, to build the house for me. Then as a US consumer, I bought this house. But you see, without the combination of Chinese steel and the US construction workers and the machineries, the US capital labor and the Chinese capital labor combined in this house. So that's produce a house I like, okay? So that's we call the simple global value chain activities. Then what is the complex global value chain activities? Basically, you say is the factor content within the products, embedding products cross national border at least twice. That's the example for iPhone. Everybody have an iPhone. The iPhone, you see, they have a label in the back. It's design California. It's assembly in China. So the Apple's engineer, they design, they have a plan, they have a blueprint. Then they export the idea. So then go to the factory of Foxconn, okay, in Zhengzhou. So they import different parts from Singapore, from Japan, from Korea, from Taiwan, then assembly in China, then export back to the United States. So this, you see, when the iPhone come back to the United States, this iPhone is not only include Chinese labor or Chinese capitals embedded the iPhone. They also include Apple's engineers payment, engineers salary, the labor, the scale labor factors embedded in the iPhone. Then come back to United States. That's cross border, say US border, US engineers as a scale labor inputs. So cross to China first, then come back to US, that cross border second time. For example, the auto products, okay? The US produce the auto export to Europe, but they have parts from Mexico. So, for example, the engine might be designed in US, then manufactured in Mexico, then come back for US to testing, then put it into a GM car, then export to European market. So that's all those things, you say, cross-border many times. They factor content cross-border for at least 2 times. That's complex GVCs. So that's basically we using intuition, using plain English to describe how we identify global value chain activities. Summary here. Oh, sorry. So basically, the accounting framework classify embed factor content. So you have to understand what is the embed factor content as GVC or no GVC activities based on whether they cross national border for production or not. Value added creation is classified as a global value chain activity only when they embed the factor content across national border for production purpose. So we consider both forward and backward industrial linkage. So the forward linkage-based decomposition view a country sector's engagement in global value chain activity from the producer perspective. It classifies a portion of GDP created in the country or sector by domestic product factor content at cross-border for production at least once as GVC production activities. And the portion of GVC created by domestic content stay within the national border in the whole production process as domestic production activities, such as the haircut. So the backward industrial linkage-based decomposition view a country sector's participation in global value chain activity from the user perspective. It traces our primary factor inputs embedded in the final products produced by country sector to its original country sector source. and consistently classify, embed domestic or foreign factor content into GVC and non-GVC production activities depends whether they have cross-national border for production or not. So the domestic input-output coefficient matrix and the input-output coefficient matrix in an inter-country input-output table we call ICIO table, and their local and global Liang TV inverse matrix are the key data set used to distinguish between domestic and foreign factor content in various production and trade activities. Because you say, just as GDP, so that is basically a concept. You say, you cannot really see the GDP. It's a estimation. For example, when a call cross Canadian border from Canadian to US, you cannot really say how much this call is made in US produced feed, or is take the Canadian grass. So basically, the value added you have by abstraction, you have to think about it, you have to use a tool. This tool here is a data set, is the input-output matrix. And also their local and global inverse as a key data set, the key parameters to do such kind of identification. So that's we have to use a mathematical tool. This mathematical tool is invented by Liang Tiff, a Nobel Prize winner. Okay, he's MIT professor. Okay, won Nobel Prize in the 70s. Okay, so basically this is like a cheese table. Okay, you can see here. Basically we have we have the we have three block here. You say the first block we call the order Z. That means it's a enigmatic transaction matrix. So all the diagonal in green is the enigmatic transaction within the countries, within each countries. Then all the off diagonal in yellow basically is the international enigmatic goods trade matrix. Okay. Then the second block is the diagonal also in blue, also in green. So basically is the first country produced the final goods consumed by each shelf. That's in diagonal. The off diagonal is the final goods in trade in final goods. The last block is in red is the total gross output. So basically the total gross output, we usually use X to denote. That's every product can be divided to enigmatic good use and final good use. Okay, so then in the origin part in the bottom, okay, basically it's the value added for each industry. Basically it's called GDP by industry. Then you can see this kind of tables. That's the column sum is equal to the row sum. That's the balance condition. So how much you produced equal to how much you used. The use equal to production. That's basically the what Liang Tiff invent this kind of accounting framework. So using this accounting framework, we can compute. So all the gross output X is equal enigmatic goods. We call the A is a Liang Tiff coefficient matrix. Basically, it's using the X, using the Z, each the enigmatic elements divided by the X. Okay, so the 1 minus A, the inverse, that's what we call Liang Tiff inverse. Basically, give you the interrelationship, the inter-industry linkage. basically you say they give you how much one unit final demand increase will cost, how much the gross output increase. So basically give you this kind of, that's just a very classic accounting framework. So I'm not basically you can look at this you say the notations, because what Z we represent the intermediate goods, Y is the final goods, X is gross output, the VA is value added for a particular country. Then we can compute the GN by GN input coefficient matrix. Okay, then you say the value added coefficient vector we can compute. You say that's value added coefficient. So we're using V represent. That's the notation. Okay. So basically, the local Liang-Tiff inverse matrix is an analytical tool to isolate pop domestic production. Okay, that's basically the tool, the mathematical tool we use to isolate. So because you say in a real world, any products will be combined by factor content from different sources, different countries. But how we can isolate them, we have to use the mathematical tool. Okay, so basically we know the exports is a GN by 1 vectors. The local Liang-Tiff inverse is also a GN by GN local matrix. You say basically you can say we're using AD to represent the diagonals of the A matrix. Then the AE is off diagonal matrix. If you say the YD is also diagonal, you say diagonal. So the off diagonal is YE. That means that is trade is off diagonals. Okay. So when the dimension is 2 equal 2, you can see what it look like. So the local Liang-Tiff matrix is the first in the first block in here, but I don't have a pointer. I don't know. You can see that it's easy to see in 2 dimensions. So basically, that's the mathematical tool we will use. So the gross output X can be split into intermediate goods and final goods. You say that's very simple to the mathematical derivation here. You say the gross output equal to intermediate goods, that's AX, then plus Y is final goods. Then further, you say the AX can further divide into ADX. That's domestic. That's the diagonals, and the plus YD is diagonals. Then the off diagonals, 2 parts. So what is the AEX plus YE? That's exports. AEX is the intermediate goods exports. YE is the final goods exports. Okay, basically like this. Okay, so the B is a global Liang-Tiff inverse. That's basically give you the inter-industry linkage here. So what is the GDP? GDP is the value added coefficient multiply the gross output is Vx. So Vx equal to the value added coefficient plus Liang-Tiff inverse, then plus then multiply Liang-Tiff inverse multiply the final demand. So this give you the VBY, basically give you a GN by GN matrix. That is the value added from the source country sector IS. Okay, IS, that's in the raw dimension. Then used in the production of final goods and the service in the country sector RJ, give you the column dimension. Okay, basically it's a GN by GN. The G is the number of countries, N is the number of sector or industries. I think this is quite easy for people working in data science. So when dimension is 2, so I always come back from dimension N GN to dimension N and G equal to 2. That's easy to illustrate. You say, basically you say the VBY matrix is just like this, okay? The V matrix is diagonals is diagonal, put all the value added coefficient in diagonal. Then the final goods is in the diagonal. Then the Liang-Tiff inverse in the middle, okay? So when we try to decompose the GDP by sectors, what do? We can sum, okay? We can go cross the rows. Okay, you see, that's like the first elements in this matrix, VBY matrix, is the V1S, B11SS multiply Y1. That's what that means. That's basically is the value added from the country S, sector 1, multiply the reactive coefficient, reactive inverse. That's called total requirement coefficient, multiply final demand of the S consumed in domestically. So that's the value added first elements. Then you see, then this value added contribute to the country S second sector, then to the contribute to the country R's first sector, then country R's second sector. So what this each element mean here is the value added produced in country S first sector, first industry, how they used in different downstream sectors. So your sum of them is the equal to sector value added. That's the sector GDP. Okay, that's the forward linkage based decomposition. If you see that you sum the downstreams, that's basically give you the backward linkage based decomposition. Basically, you see the sum, the first column equal to the value of the final products produced by sector 1 in country S. You say the country S final products come from the first sector in country S, second sector in country S, then first sector in country R, second sector in country R. So sum them together become the final goods produced in country 1, in country S. Okay, so that's basically, you see, it's very easy to recognize how to decompose by GDP or by final production. Okay, so that's basically is repeat what I just said. Okay, so basically you see the decomposition of value added and the final goods production by country and the industries. So we see the GN by GN matrix. We can, you say, that's is one matrix. What do we do here? Basically, is you decompose the GN by GN matrix into the figure we show, the 3 or 4 parts. So that means we will get 4 GN by GN matrix. Okay, the GN by GN matrix here is you say just 1 when the dimension is 2. But you see, what do we do here? We're trying to get the decomposition to identify the GVC activity as we illustrate in the figure in plain English. So basically, it's try to decompose this 1 GN by GN matrix, the VBY, into 4 GN by GN matrix. Okay, that's the purpose. So we know the D is diagonal, the E is off diagonal. Okay. So what we do is say we here is the initial goods AX plus Y is final goods is gross output. Okay. Then reactive inverse is X equal to BY. Then we do here, we go to the equation 7, you see the gross output equal to ADX plus YD. That's domestic consumption, domestic initial goods. Okay. Then you have export initial goods. That's AEX and YE export final goods. So we can simplify this as we keep the first 2 terms unchanged. We use the E exports to represent these 2 terms. Then you can take the inverse here. So basically you say that 1 of the I minus AD, this take the inverse, we multiply YD, then the local inverse, the I minus AD is local inverse, okay? Then multiply the exports. So basically you get the 2 terms. That means the local inverse multiply domestic final goods. That is one part of the gross output, okay? Then the local inverse multiply the exports you get the other part of the gross output. That's basically in order to produce the export, how much gross output you need here. Then you say we keep the RD unchanged. Then the E we know is the two terms, AEX and YE. That you get the two terms. Okay, so that's basically you decompose the BY, that's X, into three parts. That's corresponding to the graph we show here. You see that's the power domestic production, RYD, then traditional trade, RYE, then the GVC activities is the RAEX. So basically, what you do here is decompose the GN by GN matrix into three GN by GN matrix here. Okay, then further, you see we can further decompose RAEX into the RAEBY because X equal to BY. So this derivation is really simple, really simple. I think if you have some basic background, you can follow easily. So here we give the formal formulation of the decomposition. So Vx equal to Vby, that's GN by GN, one GN by GN matrix. Then we go to the VRYD, that's power domestic production. Then we have VLYE, that's the RT, that's the traditional trade. Then we have VLAEBY, that's GVC activities. So the last term, we can further divide into two parts. Okay, one is the simple GVC, then the complex GVC, the other three B's complex GVCs. So each is a GN by GN, all the four terms, each is a GN by GN matrix, summing along the row, provide the decomposition of the GDP production. Summing along the columns, provide decomposition of final goods and services. Okay, the beauty of the equation 8 or equation 9 is an in matrix form, which express both the forward and backward based decomposition in one unified formula, just by summing their elements of each matrix in different directions. So that's the beauty of this mathematical formula. I hope everybody can follow me. You see, if you have any question, you can send your question to Kirsty. Okay, Kirsty, I will be glad to answer your question. Then you say, in order to say, because sometimes it's hard to merging the GN by GN matrix. Okay, right now let us say also in 2 dimensions, what does it look like? Okay, if the dimension is 2, the 2 country, 2 sectors. So the local Liang-Tif is like this. Okay, the global Liang-Tif is like using B like this. So then what do the 4 terms look like? You see the power domestic production here. You see is VS is domestic value added. Then RSS is domestic local matrix. Then YSS is final goods consumed domestically. Okay, you see, there is no cross-border trade. It's only each country produces each country's products and consumed by each country consumer. Okay, so that's a power we call power domestic. You just see then the superscript. You can see it very clearly here. Then you can the second term. That's you have the domestic value added as country's value added, local Liang-Tif multiply the YS. Y is the final goods. From S to R is cross country. For what? For consumption. It's no productions. You see, the off diagonal is 0. It's 0. Even for the simple GVC, you see, it's complex than traditional trade. But you see in the formula here, it's VS, domestic value added, local domestic Liang-Tif, SS. Then ASR is the coefficient of trade. It's the E. Basically, it's the AE. It's off diagonals. Then you have the involved country R's local Liang-Tif involves. And the YRR, IRR is local Liang-Tif and local consumption for the second country. So that means production, you say, happens not only in country S, also happens in country R. So the factor content of country S, the labor capitals embed in their in-demand goods, that's ASR by the coefficient, the trade coefficient here. So that's cross countries. Then combine with country R, the factor content. They produce a final goods consumed in country R. Okay, so that's what we call simple GVC activity. But you see why we created the complex GVC, the term. I will later on to talk the limitations. They really have limitations. But you see the mathematics, basically what the idea we come from is, you see this complex GVC activities, the mathematical formula, even in two country case, is much complex than the other three terms. Okay, the diagonal, what is the diagonal? Diagonal basically is the factor content across country to country R first, then come back to country S. That's returned, just like the iPhone, okay? Have Apple engineer salary embedded in the iPhone design, then assembling by Foxconn, then come back, we export back to United States. But if you see the off diagonals of this, that's basically is produced, export to direct importing country, then re-export to third country. But we have only have two countries here. You cannot say that. But the off diagonal is basically you say you basically is the re-export. It's the re-export part, just like the Japanese produce the computer chip, then export to China. China make the chip into the toy, then export the toy to Europe. That's basically you say that's the Japanese factor content embed in the computer chip, then go to China, cross borders, then combine with China's production factor to make a toy, then export to the European market. So that's we call this complex GVC. So the one part of the reason we have that term is because its formula is much complex than other terms. So basically, okay, we hear you say the both way to decompose production activity in a country or sector pair include the four parts. The factor content in parts 1 and parts 2 involve no cross-country production activity. Okay, but the difference is the factor content in part 1 in the power domestic production is satisfy domestic demand only. The traditional trade is satisfy foreign demand only. But all these two parts, the production process is only happen within one country's border. There's no production factor across the national border for production purpose. Okay. But the factor content in the part 3 is embedded in trade of in-demand goods. Okay, and can be decomposed further into two parts. The 3A is value added embedded in in-demand goods absorbed by the direct importer, and where cross-border for production activity are conducted, but only within the direct importing country. Okay, just one border crossing. But some 3B is value added that cross-border at least twice to satisfy domestic and foreign final demand, respectively. Such design as complex GVC. The 3A and 3B measure cross-country production sharing activity. They always are production factor across national border at least once in the whole production process. Just because the combination of the production factors from at least two countries, its specific products and service at its specific price. This is very important, okay? So because any products have a cost. Why we have this kind of combination of different factors from different countries that produce a particular product, have particular feature at a particular price. If you come, for example, if you using the like I said, using the steel from China to produce a house, the price might be different using the steel from Europe or from Japan to make a house may be different. They may be different level of products, satisfy different level of consumers' demand. So any combination of production factor in different countries will produce a particular goods. If such production chain activity broken, you no longer have that particular products at a particular price. Okay, so that's the important thing you need to understand here. Okay, so let me sum up. Basically, you say we decompose the Gn by Gn VBY matrix into 4 parts. Okay, 4 parts. Okay, that's, you say, we have the forward linkage based producer perspective. We have the backward linkage, the user perspective. Basically, it's summing into different directions. Okay, the summing up each Gn by Gn matrix along the raw direction. We decompose value added generated from each country sector pair in terms of why it goes. So you will know the particular sector's value added, how it used in downstream sectors. Where you're summing up the Gn by Gn matrix along the common directions, they decompose country sector final goods production in terms of where this value add come from. Okay, so that's, you see, it's very easy. The mathematical derivation is quite simple, and using one formula, you have both the forward linkage and the backward linkage, the decomposition in one framework. So that's basically the mathematical framework. So all this is in very abstract mathematical term. So let us using the data. When we go to the real data, let us see what happens here. Whether this kind of decomposition make economic sense. So you can see this graph. Okay, basically we combine different data sets together. You say from 1995 to 2017. 2017, we using, they say, YR data, we using the Asian Development Bank's data. So basically you can see the blue bar is the complex GVC activity. The yellow bar is the simple GVC activity. The green bar is traditional trade. And the orange bar is the domestic domestic productions. So you can see very clearly here, when they have an economic shock, even in the 1997, we know the Asian financial crisis, you will see they have declined here. But more clearly, you can see the dot-com boom, dot-com bust in 2000 that caused the decline of the domestic domestic production, and also the simple GVC activity and the complex GVC activities. So the more dramatic is the. Catch that. Could you try again? Oh, sorry. So basically, in the 2008 global financial crisis, you can see here, you see the most dramatic decline is the complex GVC activities. Okay, and the domestic activity is declined relatively small. But in the global value chain expansion period from the 2001 to 2008, you can see when the global value chain expansion, you will see the most dramatic is the complex GVC activity. So after the financial crisis, when they recover, also is the complex GVC activity driven the recovers. But unfortunately, after 2010, you say 2011, since 2012, basically slow growth. Okay, slow growth. So you can see this kind of decomposition is really makes sense here. There are 4 different type behaviors. This 4 type of production activity behave differently within the economic circles. Let us to explain why is the case. Okay, why is the case? Okay, so we try to explain the situation here. You say this graph gives you growth rate of merchandise trade and the real GDP growth from the same period as we saw in the last graph. You see, the world maintenance trade growth is using the blue line, and the GDP, real GDP growth is in the red line. That's all in the left scale, you see, left scale. Then the ratio of trade growth to GDP growth, that means using the trade growth, that's real trade growth, divided by real GDP, is get this kind of dot here. See, it's in red scale. You can see here very clearly here, when economic get growth, especially when the trade growth higher than GDP growth, what happens here? For each year, when global real trade growth was faster than global real GDP growth, the complex GVC activity had the highest nominal rate of growth among the 4 type of activities. So you can compare. It's very interesting to compare these two graphs. Okay, compare the 2 graphs. So when the real trade growth higher than GDP growth rate, okay, always, okay, the complex GVC activity will grow faster. Actually, this is very intuitional. Okay, the reason is the complex GVC activity are the only one of these 4 components of value-added production, while the factor content embedded in products cross a national border at least twice. Because you see, GDP is a need-based accounting measure, where the gross exports, merchandise exports, trade collected by the customers is a growth-based term. It's a growth-based accounting term. Okay, different accounting principles here. Say, for GM produce a car, when they measure as GDP, they only measure value added. They will all the car cost deduct the steel they use, the rubber they use, the glass they use, the electronic component they use. They only take the value added or the salaries, the capital return, the capital profit, the depreciations, the taxes, those things into account as value added. Where when the GM car from US go to Europe, the customer will know will take all the car's value, total value, as the statistics. So that you can see. But because the production has 4 parts, we divide it into 4 parts. Okay, only the complex complex GVC activities is the factor content. The factor content is value added. Okay, they cross border for more than twice. So you have more complex GVC, you definitely have more faster growth of trade. When the trade growth slower than GDP growth, that means no much complex GVC activity happens. So all the economic growth slow down, the GVC growth rate, the trade growth rate is lower than GDP growth rate. So that is a very, very easy to understand intuitively. So why, when the economic expansion, the complex GVC activity will take the most dramatic increase. Okay. So that's the decomposition of the GDP, of the production activities. So then we taking another perspective, we consider how a firm to take a part of the GDP, the global value chain activities. So they basically have 4 ways. They can all exporting its domestic value added in medical exports used by a direct importing country to produce products for a third country. That is one way. We call this, this is forward linkage. We are forward-based participation. Then using other countries' value added to produce its gross export. That's using other countries in the medical goods to produce their own exports. That's backward. But have another way, okay? using other countries' value added to produce for its own domestic use, okay, or exporting its domestic value added in many exports used by a direct importing country to produce for domestic consumption, okay. In early literature, we call the VS and the VS1, that's basically the first two terms, okay, as proposed by Hamel in their 2001 JIE papers, only take into account the first two channels. So they didn't take into account the other two channels. So you, based on the decomposition of production activities, we can have two types of GVC participation index. The forward linkage-based GVC participation basically is using the 4 component of GDP production divided by the total sector GDP. So you get the participation rate naturally, okay? So basically what that says, what percentage of production factor employed in a country sector pair has been involved in cross-country production sharing activity, which measures domestic value added generated from GDP, GVC production and trade activity as a share of total sector value added, or GDP. Okay, that's basically the forward linkage-based participation rate. The forward linkage-based is answer, what percentage of final products produced by a country sector come from the GVC activities? It measures the percentage of a country's final goods production contributed by both domestic and foreign factor content that involve cross-country production sharing activities. That's cross-border at least twice. Okay, so that's basically the participant rate definition. So you can see here, that's globally looking. You will see the total GVC participation rate. You will see the Asian financial crisis. This is from 95 to 2009. That's the most recent data. So this will show up in the third issue of the Global Village Development Report. But you will see the decline, the global financial crisis in 2008, 2009. Then you have flat here, flat here. We have a rebound in 2017 and 2018. But unfortunately, because the US-China trade conflict, they decline again here. That's basically you say here. So that's the overall pattern using the real world data. Then another numerical example here is the decomposition of China's manufacture sector. What you can see here is also very interesting. The red line is the domestic production. Okay, the traditional trade is blue line. The symbol GVC is green line. The black line is the complex GVC activities. So especially you see the domestic production, you will see very interesting. Okay, from the 2001 to 2009, you see a U curve. Okay, the backward and forward is same way. So what does that mean? Before 2009, there is a U-shaped curve of the share of poor domestic production in both forward and backward linkage-based decomposition. But after 2009, the share of poor domestic production continued to increase. Traditional trade production decline. Cross-country production sharing GVC activity also slightly decline. What does that mean? So it's not necessarily say the GVC activity increase is, you cannot say that, you say, because you say China have been, you say, open up since 1979. So the domestic value added have a increase period. If we have more data, we can see the domestic value added has been declined because especially open up, China joined WTO. Because you open up, you import more intermediate goods, especially the processing trade. At the peak in 2006 or 2007, basically it's 55% of China's trade is processing trade. What I mean processing trade is the intermediate goods come into China tariff-free, then assembling by China, then re-export to the world market. So that's cause the domestic value-added decline, the foreign value-added increase, the GVC activity pick up. But however, as China industrialized, the more and more, the two different reasons. One reason is more FDI come into China. So for example, the Intel, before Intel have a factory in Dalian, all the China import computers, export computers is the chip is imported from other countries, from Japan, from Korea, from US. So that's China's foreign value added in computer export. But after Intel have a factory in Dalian, all this become China's domestic value added. So that's what we were talking about. That's the limitations of this method, because all the foreign firms within Chinese border produced value added will count as part of China's GDP. Okay, so that's because the recent rules of the current national accounting. Okay, national accounting rule is residence based. As long as they form register in China and they don't engage in cross-country trade activities, they produce the value added, or is China's GDP. So that's, you see, that's one reason. When FDI increased, then also another aspect of the reason is become China's form upgrading. The many in-demand goods they cannot produce in the early stage before they join WTO. But after they join WTO, they starting to produce more in-demand goods they cannot produce in the early period. So that's cause the domestic value added increase after 2006. Okay, after 2006. So that's basically you say C. So this kind of decomposition is make economic sense. So that's basically I say. Then, so do you need to compute all of this? If you know the interesting in the decomposition itself, know the interest in the mathematics, the UIBE have a team. They compute all the index for you. They already have index for you. So here you say you can click this line. Then we bring you to WTO, the GVC Global Value Chain website. Okay. Then you go down here, go down the website. You go to the that's mean UIBE website. You click the database because right now the UIBE team is working with WTO Economic and Statistical Department. They're trying to make this index more accessible to global research. Okay, basically they're using the UIBE will have a data lab established. I think maybe next year they're using the cloud to store their index. Then WTO will buy a cloud from Amazon service. So that's a better because we know have a firewall there. Sometimes the foreign researcher is difficult to get information inside China, and the Chinese researcher is difficult sometimes to go to foreign country, foreign website. So that's the we design. Say the UIB have a data lab, they have a server. Then WTO have a server service from Amazon or in cloud. Okay, so you go to right now say the WTO's Amazon cloud still not function yet, but very soon. I suppose maybe this year. I think because of the pandemic is delayed the people exchange. Say we cannot have a team go to Geneva and the WTO cannot send a team to Beijing. So that's delayed. But I think will be end of this year they will be available. So you can click here. Okay, then you click the UIB index. You go to the eFund cloud right now. You can see all the data here. You see they have different ICIO table, like for ADB, MRIO 2018, ADB YR in R. They have, you say they have GTAP, they have OECD ICIO, they have YR ICIO, different versions. You see here, all this folder in the same structure. Okay, same structure. You say the index one, the production is we are talking today about this. We're talking about here, okay? So then you say, basically, you say, how can back here? Let me see, how can, let me, okay. So I show you, you can go to the website step by step. So then I will explain how this data file is structured. You say, the folder name is called PROD, production. The folder contains 4 group data files related to GDP and the final goods production decomposition and the GVC participant index. So you see, we have the country sector level index. They basically, you say, they call forward SVA, then the ICIO name. That means you can have the OECD database, you can have the WIRE database, you can have the ICIO database, you can have the ADB database. Okay, or in CSI, they have 2 formats. One is in R, the other is the CSV format. The contain decomposition of results of sector GDP based on 4 industrial linkage. The include 15 index. Okay, 15 index. So basically, they have 3 level. They have 2 level decomposition. The first level, they have the VAD. That basically is the port domestic production. The VART is traditional trade. The VAGVC is the GVC activities. Then the second one is basically we have the GVC simple. Okay, simple GVC. Then the complex GVC, they call complex GVC C1. What is the C1? So basically, you say the 2-dimension decomposition. We're using the two-dimension matrix. That's the diagonal one. That's the returned, like the iPhone, include the Apple engineers salary. They go to China, return to US. Then the VAGVC C2. That's basically is the re-export to third countries. Okay, so that's basically the data. So you can see from there. Let me see how I can get the. So to save time, I don't think I have much time here. Oh, already passed the time. Okay, sorry. Let me try to sum up here. Okay, so that's the decomposition of GDP. Then they also have the decomposition of the backward final production. That's 3 level 2. The same. So you can look in the file called backward FGY. Then the ADB or ADB or the OECD or the ADB or here. Okay, they already compute for you. So you can direct download the files. So as long as you recognize what this means, okay, that's in the data file. The most important, we also have the decomposed production activity within source structures. So that's basically you have 6 GN by GN data file each year, corresponding to the 5 components of production plus GVC totals. See, we have why is 5 components? Because we have the diagonal complex GVC and the off diagonal. So that's the additional one. So can be used to compute GVC participation by country and the sector source. The row sum decomposes GDP. The column sum decomposes final goods production. For the country at interest, only need is row for forward linkage-based decomposition, whereas column for backward linkage-based decomposition. All files are in the same structure. Column label gives the place of production. Row label gives the year and the source of the value added. Is the value added from a source country sector, SI, that's raw labels, used in production of final goods and service in the country sector, the column labels. So then we also have a decomposition of final goods production into domestic and foreign value added. This is 2 GN by GN matrix. All those things give you the source and the destination, okay? I think I don't have time today to show you how those data can be used. So, but you see, this current database is still for research only. But what the UIB team working with W team working on is on a interactive interface is under development with W Economic and Statistical Department. So what they do, they using a I think it's 5 countries, 6 sectors example. They basically they develop a interface. Right now it's still in preliminary stage. So basically you say they give you say you can download, different sectors, you can choose sectors, you can choose countries. Then that's help you to extract the data from the database. I think that's basically, because the time is already passed, okay? I don't have so much time here. So you say so you can get the PPT here. You say basically you say how to use this data. All those data is drawn from the database. I just show you. Okay, those data can help you to understand how to use this data. Unfortunately, I don't have time. I already over time. I don't know. So today, I'm sorry. So this is the source by source. So I hope the ARMD labs can distribute this slides to you. If you have any question, you can come to you. Okay. Let me sum up here. Okay. We have a NBER working paper in 2017. We propose a production activity accounting framework based on whether fact content cross national border for production or not. The decomposition based on such a framework show that the composition of different types of production activity in global GDP has changed in past 2 decades. The GVC activity as share of GDP is increasing. The GVC production activity, especially its complex part, co-move strongly with the growth of global GDP, both in boom and in recessions. By estimating those index according to real-world data, it can produce a large set of indicators and put them online for public access. Despite their limitations, this index could be widely used by both theoretical and empirical economists in advancing studies for economics of global supply chains. So that's basically, I say, I have a lot of things stuff here. I just maybe too long. I spent too much time to explain the concept. I should have more time put in later. Okay.
No worries.
I should stop here. If you have any questions, you can write to me. I will be glad to answer your questions by email. Thank you very much.
Thank you, Dr. Wang. Thank you so much. And thank you everyone for joining us today. A few things before we close out the day. You can find Dr. Wang on our expert portal on grmds.org. And if you're not already a member, make sure you go and sign up today so that you are able to find him on our expert portal. And then also, if you are interested in speaking in a webinar in the future, please contact us in the expert portal on grmds.org. Again, thank you, Dr. Wang, for your time. And again, thank you, everyone. You will be receiving the PowerPoint as well. That will be emailed to you. So thank you, everyone, and we will see you again soon.
Thank you, Dr. Wang. Thank you, Christy, and thank you, Erica.
Oh, thank you, man. I think I didn't control my time well. Okay,
no,
sorry.
you did good. You did good. We'll for sure make sure they know how to contact you in our follow-up email.
Okay. If they have any questions, please forward to me.
Okay, will do. Thank you so much, Dr. Wang.
Thank you. I'm enjoying it. Thank you.
Thank you. Bye-bye.